Hi, Assalamualaikum. Today I would like to present my research methodology and pre-project titled Numerical Modeling of Leka Replacement in Geotechnical. My name is Nur Ainaa binti Hasbullah, ID AA17192. My supervisor is Engineer Dr. Ainaa binti Based on the research made by Teh and Rosali 2017, Malaysian soils vary widely in texture from as low as 3% sandy soils to over 90% clayey soils of clay content. The mean sand content of Malaysian soil is 41%, which is nearly the same as that of the clay content, 43%. Therefore, it is clear that the soils in the region of Malaysia is mostly soft soil, and as generally, this type of soil are low in shear strength and high compressibility. Besides, it is instability in settlement. In this study, replacement is the best measure in terms of soil improvement in order to overcome the soft soils problem. Leka, or their other name is lightweight expanded clay aggregate, is used as alternative material for the replacement. In this study, it covers three objectives. Firstly, to study the physical properties of leka. Secondly, to improve the settlement criteria of soft soil by using leka replacement and numerical modeling. Thirdly, to determine the relationship that can be established between the various types of leka availability and soft soil. In this study, it covers the scope of numerical modeling and lab testing. So therefore, for the numerical modeling, software is used in order to identify the result, which is Plexis 3D foundation, and lab testing as a verification for the numerical analysis. In this study, more column is used for the analysis modeling with train type. There are about 50 models are analyzed based on the defined depth of replacement, which chosen based on previous study of leka replacement and recommended thickness. Coefficient of E, which is void ratio, is used as the variable of the study. The volume of the voids need to be reducing in order for the soils to reduce its saturation and thus increase its settlement. The magnitude of the settlement is taken based on the study made by Azhani Zukri, Ramli Nazir, and Ng Yen 2018, which the settlement is taken about 0.3153 for untreated soil of 15 kilonewton meter square uniform per meter square uniform load, analyzed using software Plexis 3D. The result is predicted by soft soil model while using more column. Okay, for the literature review, I will cover about two subtopics, which is soil replacement and leka. What is soil replacement? Soil replacement is a process which involves removing and replacing low quality of soils with much more stable soil or material to achieve desired properties of soil. The reason for this soil replacement is because it is considered to be the simplest and oldest way of soil improvement method. At times, it is more economical, reliable, well established, and requires less time. Therefore, it can help to speed up the construction process. Okay, what is leka? Leka, or their other name is lightweight expanded clay aggregate, is a lightweight aggregate made by heating clay to around 1200 degrees Celsius in a rotary kiln. It is already being used in many civil engineering works due to its low weight, high strength, and favorable drainage characteristic. And in terms of the dimension, leka particles can be classified as gravel. Okay, this is the summary of the literature review that I have referred in order to conduct this study. There are about more than 5 literature review. However, in this slide, I show you only 5 that are most significant to my study. The first is from study made by Azhani Zukri, Ramli Nazir and Ng Kok Shien in year 2018. Second year is from A.K. Gabriel, 2012. Next, Basim Jabar Abbas, 2016. Sharif El Shahid Saad, 2007. And Murad Ornat Mustafa Laman Ahmed Demir Abdul Lazim Gilzid, 2012. So based on these 5 authors, they use different materials for their replacement. Some use lacquer, sand, granular fill, and common aggregate. Okay, for the first author, Azhani Zukri, Ramli Nazir, and Ng Kok Shien, they use finite element method by using Plexus 3D software, and they verified their result by using the Zaki equation. So based on their result, they find that settlement decrease with increasing the thickness of lacquer replacement. And then secondly, A.K. Gabriel. He conducted the centrifuge test as main work of the study, while numerical modeling by using software Plexus 2005 as a verification process. For the type of material, he used gravel, and the result shown that the replacement can reduce the settlement and thus construction costs. Basim Jabar is analyzed their study also using finite element method using Plexus 3D and compare their result using Jangu equation. Also, the result shown that settlement is decreased with the thickness increase. So we move to the chapter 3, methodology. Okay, for chapter 3, methodology, my study start with defining the problem statement and then move to the literature review, methodology, which include 2 methodology, physical properties testing and numerical modeling. And then I analyze the result and make conclusion. And then I end my study. My first expected result is physical properties of lacquer. And then secondly, mode shape of settlement improvement factor or settlement graph. Thirdly, decreasing in magnitude of settlement of soft soil. Here I attach my planning on PSM1 and PSM2. For PSM1, I cover tasks starting from briefing of FYP and then move to the selection of title, identifying related field of study, defining the problem statement, objective, scope of study, literature review, methodology, and then I prepare, and then for week 14 until 15, I prepare for the online presentation, which is this video, and then proceed to the panel evaluation and submission of final draft. For the next semester, I will start my lab testing first, and then conduct at the same time, I will conduct my numerical analysis. Then on week 4, I will analyze my result. By week 7 of next semester, I will start my discussion and then conclusion and preparing for the compiling all chapters from chapter 1 until 5. So that's all from me. Thank you.